Hi, welcome to another ransomware analysis video where today we'll be looking at Karo. So this is a sample which I'm downloading the document for it here. It was distributed as a Word document through like phishing emails. Most of the instances I've seen were password protected, which made it quite hard to perform any kind of static analysis on it before actually opening the document. So this instance I've actually got one without the password on it, so whenever you open it in Word it won't ask you for the password. So it means that we can use a couple of tools in here. So I've downloaded the sample. I will just show the VirusTool status, so it's detected as 33 out of 60. The ones that actually had the password in it, I was seeing ones that weren't detected at all. So it's a good technique to try and bypass a lot of security products, but obviously the user having to enter a password is something which might raise suspicion. So we can use some tools to actually analyze Office documents in here. For example, we can see from this here that there's forms in here, Visual Basic Scripts. If we want to get a bit more information then, because we know it's VBA, we can run that again with the VBA script, and this is pretty cool. It shows you some of the code that's actually going to run. As far as I'm aware, this is saying that it'll run msbus24.exe from your temp folder if num is less than or equal to 20. I think this is after it's done a certain amount of pings. It's just kind of putting a delay on before running the sample that it's going to go and fetch, and it's going to hide the Visual Basic Script. There's not going to be any real notification. The user's not going to know that it's executing. What else can we see here? We can see a PowerShell, PowerShell.exe. PowerShell is going to be run with this command as a hidden. It's going to be hidden. It's going to download this file from a .onion address, which is the msbus24, and it's going to store it in the temp folder. Here it's quite nice to get some kind of indicators of compromise, some suspicious things which is detected in the document. So running an executable, automatically executing it when the document's opened, hiding the Visual Basic Script, running a PowerShell command, downloading a file from the internet, creating a text file, etc. Hex strings, you can add decode there, but if I add decode, I don't think it doesn't really give us any more meaningful information. And then indicators of compromise, so this URL, which is going to fetch the file from the actual exe itself, and yeah, pretty cool tool. So I'm going to jump over to the Windows 10 system and actually have a look at the document. If I'm going to open up Process Hacker for now, and Wireshark as well. And I'll start the traffic capture, go and have a look at the document. Okay. So we open the document. This one doesn't ask us for a password. It will ask us to enable the macros. So there isn't really anything in the document. With the email advises it's going to be something to do with a credit card payment or something like that, and you're going to be charged unless you have a look at this document. So you have a look at it, saying you can't find out why you're going to be charged or what the charge is for unless you hit enable content. So let's move this down a bit. Okay, and hit enable content. So we've enabled that, and we should see in the traffic capture that it makes the request. Yeah, okay, so it's made the request there to try and pick up that .exe from the onion address. The problem is it's showing that it's been moved permanently. So I had a look at a couple of samples, a couple of the documents, and this seemed to be happening for me on each. It will try, and it'll keep trying to get it, so maybe the site's just down while I've been trying to test it. Maybe it's been taken down altogether. I'm sure it's being hosted in other places, but I'm more really interested about the actual payload rather than the document. So you can see there the PowerShell command was running. We have timeout, so it's waiting. Every now and then it will try and execute the PowerShell command again. So we'll see if we see it pop up. Okay. Yep, there we go. So it's popped up. You can see that it was trying to run this in a command line, which is exactly what we saw whenever we were looking in Remnux. But it's not able to get it, so it's just going to keep going for it and doing that. So I'm going to close down the document, and what I'll do, I'll revert this snapshot. We're going to go back and have a look at the actual exe file. So I'll revert the snapshot just so we're not getting anything, just so it's not continuously trying to reach out to that at all. Okay, so reverted to the original snapshot there. This time I'm going to have a look at the exe. So rename that .exe. I'll just jump back actually, and we'll download this exe from VirusTool and just have a look at it in Remnux before we open it in IDA Pro. So as usual, just any portable executable information analyzing tool like pscanner or pdump or something like that. Check the strings. I like to do greater than 10 just to skip out a lot of the kind of shorter strings which are often just kind of garbage. So it's called for, there we go. Okay, so we can see quite a lot of functions in this. If you were to search right through them, you'll probably see some pretty interesting ones. DES, crypto, service provider, create decryptor, crypto stream, anything which mentions crypto in it, and this exe, there's a good chance it's going to be ransomware related. Encryption. Okay, deleting folders, moving folders, overwriting files, get drive names, picking up information about the system. Okay, quite a lot of functions in here. Random number generator. Download file. Okay, yeah, a lot of functions. So if you sit and go through those pretty carefully, you'll see a lot which would give you a hint as to whether the exe is malicious or not. We know it's malicious. I'm not going to spend a long time sitting searching through every one of those functions. The PE scanner didn't really pick up too much about it. It's not giving us any. You can see an imported DLL. It's not listing us any functions there or any suspicious alerts or anything like that. So again, back to the Windows 10 system. Open this up in IDA Pro. Okay, we can see there it's Microsoft.NET assembly. So Generally, whenever we get a sample that's done in .NET, we'll go and use the Nspire to get a more readable code. You can see that this code is not readable at all. It's been obfuscated. We've got hex values being called there. No string sitting around, and I think it's because of this smart assembly has been used when compiling it. So even I think if I go in and look for strings, no strings at all. So not much good. So again, because it is .NET, we'll go and have a look at it anyway in not the document, in Nspire. Okay, so go to the main form. But again, you can see that this is just as heavily obfuscated. It's not an easy piece of code to work out what's going on, because the smart assembly feature has been used. So you can see here, smart assembly. So my initial reaction to this is to, whenever I see a lot of obfuscation used, which I'm not too sure of the best tools to try and de-obfuscate, or if there's anti-analysis techniques that have been used to try and stop static analysis, I'll normally just go in and run it. I will go in and run it now just to show what'll happen, but this malware also uses anti-analysis techniques to prevent dynamic analysis, so we'll see more of that in a moment. But I'll just open up a couple of tools here just to kind of show you how I would go through it and how I'd be thinking, whenever I come across something like that. My first thing I would do is jump in and just have a look at it, the dynamic, what happens when you run it. So I'm going to put a filter on this because it's just going to get flooded with events. So I'll put this down to process create. Normally what I like to do then is, once I see a process created, which is clearly the malware, spawned by the malware, I'll then follow that just by name. So anything it does, creating files, deleting files, changing the registry, anything it does from there, that's all you're really going to see. If obviously it spawns a couple of different processes, and you'll want to follow each of them by name if that's what you're trying to do anyway. But so we've got those running. Did I start the traffic capture? No. So start traffic capture and run the sample. Okay, so we run it, see it running there. Ping.exe was called. So I think this is to do with the kind of delay that they tried to put on it. But you see pretty quickly it's gone. It was called and it didn't really do anything. No network activity. It's not really done anything on the system. If I go to include, nope, that's all it did. It just ran command prompt and then failed. So at this stage, it was pretty clear that dynamic analysis wasn't going to work for me, and because the code is so heavily obfuscated, it's hard to see what anti-analysis techniques they've actually got in there in order to maybe go in and change the code and reassemble it, recompile it, and try it again. But so there is a tool we have here, d4dot, which if I pass the exe file into, this is actually made to disassemble smart assembly. So it's created a cleaned version So if I now go back to the exe folder, you see we have cleaned. So I'll go back to Nspire with the new cleaned version. And go and have a look at the main form again. And straight away you see this is a lot more readable. So, and this is why it wasn't running for us. So one of the first things it goes to do here is to check if there is any mention of VMware or VirtualBox, and if so, set this flag to true and basically don't run. So I'll open up, I can see some base64 encoded values there, so I would normally just run this through the command line, but since I'm not on my Remnix box, it's not easy to just copy and paste between two VMs in virtual VMware workstation. Okay, so that was the ping. So it's running the ping 5 times just on a local address and deleting the file from temp. Okay, let's see here. So if flag, so if it found VirtualBox, if it found VMware, it's setting the flag to true, and then if the flag's true, then it's going to basically delete any presence of itself, delete whatever it's put in the temp folder. And let's see what the other bit was doing. Okay, so it's running command prompt, and then it's running that it's putting those arguments through, which, oops. Okay. Okay, so you should be able to just really make some changes. I would have thought to samples like this, you know, just change that to if it detects VirtualBox, set the flag to false, or just skip this entirely. For some reason, trying to run it and debugging it, or trying to change this value and recompile it, doesn't seem to be working for me. I don't know whether I'm missing other dependencies on my computer on this virtual machine, should I say. It's fresh install, and I haven't really installed many of the requirements that come with, for example, Visual Studio and stuff like that, which would be used generally to develop .NET applications like this. So what else is going on in here? So servicehost.exe, this is what the malware will disguise itself as, which you'll see running. If you can get the malware to run, you'll see it running in Process Hacker or your Task Manager. We can see that it's going to create a directory, and this is for Tor, so I know that it downloads an instance of Tor so that you can go and make the payment, presumably. Download file here, which I'm assuming is Tor. Again, we can copy that. Oops. Decode it, and yep, it's going to download a Tor browser. Tor RC, so it's going to be setting some of the Tor properties by the looks of it, some of the config. I'm not going to spend too much time decoding all of these base64 encoded values. just out of interest, I'll go through a couple of them. Okay, another onion address, control and UID. It's going to put in username, OS and PC name by the looks of it, so whether that's sending that off to the command and control server, something like that, not too sure. Just to get an idea here how many base64 encoded values we actually have. Quite a lot. I'm not going to spend too much more time on this. I'm conscious that the video's getting quite long, and a lot of you are probably bored watching it by now if you've stuck it out this long. Okay, so this is going to be the ransom note. You've been affected with ransomware. You have a link there to pricing. All your files have been encrypted, which means you won't be able to open them or view them properly. It does not mean they are damaged. You will need to decrypt files, and only we can decrypt them, so you need to pay us money if you want your files back. Once payment is made, you'll be given a special file to run, and once you run that file, everything will get back to normal. All your files will be unlocked, and this ransomware will get removed from your PC. Okay, so download Tor, although they should have put it on your system already. I must say, I think that's a nice feature. You know, I run some ransomware samples. I already have Tor on this VM, and they encrypt Tor. I think it would make sense for the ransomware authors to either exclude the Tor directory when encrypting, or to install Tor. You know, if they're trying to make it easier for people to pay the ransom, then you would think that they would do that. And considering some of this, some of the other techniques they've used in this, in terms of the embedding, in terms of the actual delivery method of the document, and the anti-analysis techniques they've used for both to prevent static and dynamic analysis in this, you would kind of think that they would have, well, I suppose they install Tor for you on this. I'm not too sure whether they'll actually encrypt Tor if you already have it, but so yeah, we have our list of file extensions. These are the file extensions. It's going to encrypt. 1, 2, 3, 4, 5, 6. Alright, like 30 extensions there or something, 32 extensions. And it's going to run through the encryption process. Okay, so I'm going to end this video here. I'm conscious that it's gone on quite a long time, but I hope some of this has been useful. We've gone through a couple of different tools, particularly the deobfuscation of the smart assembly, and actually looking at some of the tools to analyze documents in Remnux. If you have any questions or comments, as ever, please leave one below, and like and subscribe.